So, I always say seeing is believing. So we have today for you a live demo. And if you remember the story that John gave and Marie and the busy soccer mom, I mean, moms are very busy. And so what we've done, we've replicated a navigation system that's very similar to today, what you find in your car. And the benefits you'll see here can also apply to any other voice-enabled applications like music search or command and control in your car system. So now what I'm going to do is ask Michelle to come back up. And so we're going to process her voice in real time using today's hardware solution, running a typical acoustic database. And what we'll see, on the left-hand side, you see on the top is the latency. And latency we define as the time it takes to decode her voice. And on the bottom is the CPU load in terms of how much resources were used to decode her voice. And then what we have also on the right-hand side is Google Maps. So what she actually says in the address will be decoded and shown up on the Google Maps. So Michelle, if you can now speak into the system and show the audience where our Austin Fab is located in Texas.
5204 East Ben White Boulevard, Austin, Texas.
So as you can see, the system is going through the 3 phases of trying to decode her voice and figure out what she said in the address. And it took 8.7 seconds for latency to determine that. And we normalized CPU load. So the CPU load is using 100% of its resources just to get to that point. And as you can see in the Google Maps, that's what's the address. So now for the second demo, what we're going to do is add the coprocessor in the mix. However, for Michelle's voice, we've actually recorded from the first demo so that it's a fair comparison. So now I'm going to ask Venkat to run the second demo.
5204 East Ben White Boulevard, Austin, Texas.
As you can see, we've gone from 8.7 seconds down to 3.4 seconds, which is a 62% reduction in time. At the same time, you see the CPU load reduction go from 100% down to 49%, which is a 51% reduction in time. And this is huge. This is what Michael's been talking about, how the processing power is so important so you can get the best user experience. So what does this mean for Marie? Marie can get to her they can decode where she wants to go through the soccer field or to Starbucks 50% faster, or in this case, 62%. At the same time, the CPU is free to do other things, like John said, music search or watching videos. So this is a huge benefit from the user experience.